Hi, Joachim.
Hi, it's great seeing you again.
Great seeing you too.
What a location.
I've been looking so much forward to having dinner with you one of these days. That still works, I guess.
Yes. All right. So I understand you have a lot of questions.
I think what would be good is to maybe start this interview by answering why we are doing what we are doing now. I mean, having dinner instead of having a, let's say, more formal Zoom interview. So just to put things back in context, I remember we were trying to come up with a fun way to do this. And so I suggested having a drink, having dinner, and then you immediately suggested to watch the movie My Dinner with Andre to have some inspiration. And so maybe the first question is, why this movie?
Well, the movie itself is I think it was a sensation at the time because it is a full-length movie of just two guys sitting across from each other, and it's animated really by the whole intellectual discourse, and it's really funny that it absolutely works. It works because the people are just so into their journeys, and in fact, I can't even remember what they were talking about. All I remember is this very animated conversation. And what's the guy's name? Wallace, right?
Wallace. Yeah.
Wallace? Yeah. Okay. So I turned up at a reading by him in New York City, and I got an autograph by him on a book that I bought by him. And as somebody in the audience took a picture of me getting an autograph from him, and sent me this picture afterwards. So it's really I was very proud to have a picture together with him.
I bet you were. It is indeed a very captivating movie, and you just cannot stop listening during the whole nearly 2 hour time. As I told you, I remember I watched it like 10 years ago. It was dubbed in French, which is always awful, actually. So I just rewatch it when you need it.
Like everything in Europe is dubbed.
It doesn't work quite well. It's by far less captivating. So I still have it fresh in my mind. And there are a few things that I just really can't shake off my mind. And so one of the things that really marked me, I mean, this is something that Andre was telling Wallace near the end of the movie about how our world has changed, how people have changed, and basically how things are just so much different, and how people can react to what we call reality today, which is funny. So we are really we think we're living some kind of a strange era where truth and reality is merely a relativistic concept.
Yeah. Well, I mean, they really don't react to the facts, but to government mandates and orders that are derived from these facts. So these are contested, and so here in America, there's this very strong strain of liberty and independence, and you don't want to be bossed around. And on the other hand, obviously the community needs to protect itself, and there needs to be like seatbelts and whatever. So for a very long time, people simply took this as took it completely as granted that the government is going to act in their favor, and then now all of a sudden you have these people who are trying to contest everything, and it's a serious problem which probably tears the entire society apart. And I think you have probably similar movements in Paris, in France. I'm aware of demonstrations that have also been taking place there.
Yeah, absolutely. We have such people as well. Yeah, I mean, so it's just very astonishing that people would react would just neglect the facts and react to the government that is trying to give orders in the direction of saving lives. It's so absurd. I mean,
it's very difficult to. I mean, I've seen conversations with these kinds of people, and they go sort of completely nowhere. There's certain things that you can't get beyond a certain barrier.
So, Joachim, maybe a good place to start this interview is by talking a little bit, if you don't mind, about a period of your childhood where you probably knew that you wanted to become a scientist. When was that? How did you grow up? Where did you grow up?
I grew up in Weidenau, which is now part of Siegen, which is a relatively small town, 100 kilometers east from Bonn.
Okay.
And it's traditionally it's a place where iron was mined and manufactured. It goes all the way back to the Celts, and so it's a very interesting place. It's very secluded, has its own language in a way. It's its own dialect, and so I was just very interested in things around me, and I remember that at the age of 8, I did experiments. It's I had little bottles, filled them with all kinds of things, and let them react and watch what's happening. I was interested in plants. So I was sort of a scientist without knowing what science really was at a very early age.
Any interesting experiment you want to share? At that time, were you mixing random?
I don't know where I read this, but I heard that by heating coal, a flammable gas would come out, and so I crushed coal and put it into a container, a sealed container, which had some kind of an outlet, and then heated it up from below, and then found that in fact at the outlet you could light a gas. Okay, so I just built this whole contraption just on some anecdotal evidence, and at the time already I was always looking for things, for contraptions that I could put together in some way. So whenever I found something which could be a metal cylinder or a cord, anything, I always hoarded them with a view on possible experiments that I could do with them. So I had a whole accumulation of things like that at this place, which is it was under the veranda of my parents' house. That was my little empire there. And so that's the kind of thing that I kept going. One thing was, I remember I found tar on the street, which was sort of, tar is always hard until you heat it up a little bit, and then you can mold it, you can form it into anything you want. So I took the tar and made something that was like a pencil out of it, and then I could write with that pencil, and it was like a great thing. It was my self-made pencil or pen.
How old were you at that time?
I was 8 years old.
Okay.
8 to 9 years. Yeah, that's the time. I played on the street with other people as well, but then I also went complete my own ways, and there were a few people who had this kind of interest. I tried to draw them in and was very excited about my discoveries, but most of the people just prefer to do something on the street.
Oh, I bet they do. So then how and when actually did you come to immigrate to the US? How did this happen?
Well, this is really I never felt it was an emigration because I never had the intention to simply stay. So it was really in stages. In 1970, I got my PhD, and before that, I had applied to or was nominated for a very, very prestigious fellowship, the Harkness Fellowship. And a Harkness Fellowship is a fellowship that brings young scientists to the United States. It's designed to sponsor cross national communication, and so I was able to go to the United States for 2 years, and then came back to Germany for a few months, and but I couldn't find a place. I couldn't find a place as a postdoc. But then there was an opportunity that opened up in England at the Cavendish Lab, which I only later found out is a very prestigious and very famous place. So, so I spent some time there, and while I was there, I got an offer for a senior scientist position from the States, from Albany. Mm-hmm. And at the time, I had not even been looking very hard for a position, and this was a straight offer. It was not. They didn't ask me to apply for it. It was simply an offer, and that came about because somehow they had the impression that I was an international specialist on image processing, and they only got this impression because I had written a review article on the subject matter of image processing and electron microscopy, and it might have been the first ever review article on it. So I simply scraped together all the different things that I could find about that subject matter and put it together in a review article. So I was the international expert. and so it came about that I got this very great position, which didn't involve any teaching. It was simply a research scientist position offered by the New York State Department of Health.
Amazing. And did you try to consider other places before you accept this position, or it was just the perfect opportunity for what you wanted to do?
No, I didn't. I didn't feel I had any leverage. I didn't try it out. I talked to some people, and they said, you would be crazy if you didn't take it, right? So, and I was. It was not just a position; it was like a group leader position, where I could hire somebody as an who would assist me in this whole thing. The whole idea was I was gonna start an image processing position. I was gonna start an image processing lab that would be dedicated to support the electron microscopy group. So, and Don Parson, who hired me, it was his idea that he came from the Cancer Institute in Buffalo, the Roswell Park Memorial Institute, and he, which was focused on cancer research. Mm-hmm. He was a physicist, and he had, it was in his mind was that all cancers were caused by viruses. And the reason why the viruses had not been found yet was simply a sampling problem. Okay, so one had to really look at thick material in order to find the viruses. So hence one needed a high voltage microscope, more than 1 million volts. And then of course there is the problem if you have thick sections and then take images, then everything is overlapped on top of each other. So along with this whole idea came the idea that an image processing group had to be formed to do something like tomographic reconstruction. So it was all part of this whole idea of viruses causing all the cancers. Okay, and he was going to make a breakthrough with this huge investment in both in instrumentation and in personnel. So you see, I never thought it was an immigration because it was sort of everything happened stepwise, and then I was established over there. So it was almost as if it would have been an immigration back to Germany. And in Germany, there was really nothing that would have kept me very much, except of course my family and so forth. But there was another factor involved, which is which occurred to me afterwards. It was a liberation for me because of the opportunity to immerse myself in a completely different language, in English, to go away from German. And German, I had the feeling, had been contaminated by the Nazi time. So in terms of expression as a writer, and I really thought of myself also as a writer, some parts of the language could not be used anymore. And it was a liberation to get out of that system and immerse myself in English.
So this is something that some people who are closer to you know or knew for quite a while, that you are a writer. So I had the pleasure of purchasing your novel that is on Amazon. It's called And Z. I have to say I'm very surprised of to see you in this exercise. Of course, it's obvious that you're a master in writing in English, probably in other languages like German, but the it's such a different style than what we are used to as scientists, writing a paper relating the facts only in a very, let's say, naked form, without all the beautiful flowery language that you would use in a novel.
But that's the very reason, because it offers me an escape to a completely, I mean, a less rigid kind of environment.
But I wonder how. So okay, when you read the novel, of course, it's fantastic, but it's obvious that it's not your first. But I didn't see I never read anything before, any fiction that you wrote before. So probably it's only me. But we feel that there's a long past of writing essays. Can you say something about this? Did you ever publish before other novels?
No, no, that was the first novel that I published. I published over the years. I published many short stories, even a few poems, and but the short story. I mean, I really like the short story format, and I like authors like John Cheever and Raymond Carver. And Alice Munro, and it is it is very, very challenging to write a good short story, and I thought it was a challenge that I should somehow master. And so I really got into English writing while I was already in Germany, because I had to write scientific articles in German, and some of them, and I did fiction writing in German before, and so when I got into the English realm of language, I try to find opportunities to develop my English as a second language, and so I got involved in writers groups, but also I was lucky to be accepted into a fiction writing class at SUNY Albany, and then later on I went to fiction writing workshops at the Skidmore College. They take place every summer, and they're organized by the New York Writers Institute. And the New York Writers Institute was founded by William Kennedy after the big success of his book, The Iron Beat. And I was incredibly lucky to be able to take writing classes from William Kennedy. That was very early, even before he published his book. I attended the class by him, and it was he who, when I delivered a short story, it was he who said, this is going to be a novel. Okay, this is much more material. You can expand on it, and this actually was the seed for Anse, for the book Anse. So it took me a very long time to actually write a novel, which expanded it in different directions. But meanwhile, as I was writing, and meanwhile I have 4 novels sitting that are unpublished. But meanwhile, I was able to send in short stories, and some of them got published. And then over the time, I must have 50 published short stories and fast fiction, poems, and so forth.
How does this writing passion relates to your work as a scientist? Does it feed? Does your scientist work feed on your liberty?
Well, in fiction writing, precision is very is an asset, and I'm very precise in my writing in science, and when I try to express something, and it can be very nebulous as a concept, but I try to describe it very precisely. And I don't know whether you have observations from reading Anze, but if you look at the the emotional movements and the inner contemplations and so forth, I've been trying to be very precise in expressing these.
It is extremely genuine and pretty authentic. Thank you.
Okay, Paul,
there you go. Yeah, I'm getting my main course.
Very good.
What are you having?
This is codfish, paneer, what is with bread crumbs, and some beautiful potatoes.
Nice.
And garni with slices of lemon.
Ooh, that's fancy. Well, I'm having a fillet. It's a beef fillet.
Mm-hmm.
It's French beef. It's garnished with its potatoes. Well, what were we saying? Yes, we're talking about the inspiration of the main protagonist.
Well, the inspiration, it's really, you walk around, you have observations, many observations that have nothing to do with science. You live in the current world, and you have accumulated anecdotes, personal anecdotes. And then, I project them into certain characters. I find it easiest to project myself into a character who is also a scientist, because there are certain habits that a scientist has, and I'm sort of feel in my element. But that scientist, which was Hubert in the case of Anze, is not a personification of myself, but rather maybe he has certain habits of observation, habits of contemplation, or some kind of inner life that keeps him going in the same way as it keeps me going. And part of it is also that very early on I developed a habit of expressing myself in writing. So the character Hubert, he also sits down and writes something down. Okay, it's just like a habit. He as a person, he cannot conceive of himself without having this kind of separate, detached existence.
Once you get your position in Albany, okay, that was a good first step, because this doesn't make a Nobel laureate, right, to have a position. What was the thinking? What was the breakthrough?
I was lucky. I was lucky when I arrived there, because the high voltage microscope was still in boxes and was sitting in boxes for an entire year. So I couldn't. There were no big pictures from that electron microscope. So during that time, I had time to develop further ideas that had already been implanted before, which is really was the idea of single particle and the single particle approach. The idea that you could just take molecules in solution, freeze them, not freeze them, there was no freezing at the time, but you had molecules in different orientations, took snapshots, and then try to get the three-dimensional structure from all these random projections. So this is the idea that developed very early on, but I didn't have the means to work on it. I didn't have computer power. I didn't have the I didn't have the leisure to actually write programs for this. And in Albany, it was really I had a very secure position all of a sudden, and the fact that the high voltage microscope was not working was instrumental for me to start really serious with the single particle reconstruction approach. So by the time the high voltage microscope was put together, and by the time it then started to work, there was another year went by. So meanwhile, I was already on a completely different track. And that was the fortunate thing that I did not get too much involved in a project that that took much longer. It took much longer for electron tomography to actually work in conjunction with the high voltage microscope. And it was held up by the fact that the recording medium was so terrible, and by the fact that there was no cryo techniques available at the time. So any material had to be embedded in plastic, which produced all kinds of deformations and artifacts. So it was sort of a certain time window in which I could develop single particle techniques, even though there were no cryo methods available, but you could still develop them with negative staining. So I was able to develop programs, and then I realized that it's not just writing a program, it is writing an entire system of programs. And I was able to recruit people who could help me doing that. And I was at many different stages. I was very lucky with the kinds of people that I managed to get interested and who could work on all this development.
So for those who don't know the story, your first, let's say, working workflow or image processing micro language it's called Spider. It's still in use today, but that back then that was probably the only tool that existed that really worked, and you were through which you were able to process images.
It was written in Fortran, which at the time was an advanced language, and so it became a very huge system, and it had the sort of a macro language, the script language, and the important thing there was that it allowed people who were not really mathematically and computationally inclined also to participate in development of programs. because they could simply say MA if they wanted to mask out something from an image, or they said FT if they wanted the Fourier transform the image. And they didn't have to worry about how it was done actually on the lower level. And so I was able to essentially get an entire community interested in developing image processing approaches. So including people who simply only had a biochemistry background.
That was probably the challenge, to interest biologists and biochemists, or more molecular biologists in a larger sense, to work on these problems and to use this technology for sure.
Maybe I should mention a woman, her name is Adriana Bershore, who very early joined my group, and the way it worked was, she was working in the in the library of the Wadsworth Center, and and she assisted somebody with screening manuscripts. Because the Wadsworth Center did not allow anything to pass out that had not been checked and scrutinized for grammar and so forth. This was pretty weird, but that's what was in place. So as an assistant to this director, she got to read these manuscripts where I explained the whole single particle approach and so forth. So she got so interested in this that she made a petition to the director to get transferred to my group. so that was I mean, it's like blasphemy in a government system, right? But she managed to do this. She managed to she simply wanted to try. And I saw she was a very intelligent person, and I said, sure, sure, I'd take anybody at this point, because I had a group of 3 or 4 people at the time. So then she became sort of a really good soldier. She did an amazing number of image processing, that essentially is already defined, but it had to be applied to so and so many images, and she could also creatively contribute to the development. So it was a pretty amazing story. And then she enrolled in the graduate program at SUNY Albany, and got a PhD.
So this is one of the key people with whom you worked back then.
Back then, it was very important that I had somebody like this that I could rely on, and who was very meticulous in what she carried out. But the beginning of the spider really goes back to 2 people. One was the master student at SUNY Albany, and the other one was an undergraduate. And both were really brilliant students, and they essentially made this entire early development of spider possible.
Who are these people?
I lost track of them. Helen Dowser was one. She was a computer scientist. And the other one was Brian Shimkin. And I don't know what happened to him afterwards. So they were not visible in the literature afterwards.
So there is someone whom you speak pretty fondly. I heard his name several times. I think his name is Jeanpierre. I don't know if I'm pronouncing his name correctly in French. Can you tell us what was his contribution in a way?
Well, that was very interesting. So that goes back right at the beginning, after we implemented all these fundamental kind of image processing routines in the spider system. But then, obviously the question came up, what do you do? How do you sort molecules that have different conformations and have different viewing directions? How do you sort them out? There was really the weak point of the whole approach, because we don't want to do it subjectively by a visual analysis. So we had to find a computing way of doing it. And so I had the student from the Netherlands who worked with Van Broeken. His name was what was his name again? Marijn van Heel. And so he got interested in the entire problem and asked to visit me for a few weeks because he had micrographs of hemocyanin which displayed all kinds of different views, and he was interested in how to sort these out. So I agreed to take him on, and then he worked and tried to write programs that would do the job. But meanwhile, I was at the in the computer room, and you have to understand, at the time, this very large place, the Watford Center, had one single computer. And to use it, you had to go into the computer room and then, wait in line or whatever in order to get your turn. And with all kinds of things going on, there were these heavy printers that worked like drums, and these very large cupboards of computers. So this is really where people who were from completely different disciplines would meet and talk to each other. And so as we were trying to solve this problem that I talked to you about, I saw a person who turned out to be Jeanpierre. He was bent over the line printer, as it spewed out pages and pages that had clusters printed on it. And I asked what these clusters were. And so these clusters were clusters of patients that had the same kind of blood sample characteristics. So blood sample characteristic is like a vector with different measurements of cholesterol and whatever. And so there was a way of sorting all these data, and it clustered beautifully. And then I immediately made this connection and thought, patients can be images, and these samples can be the pixels. Okay, so once you align images, then the pixels all have the same meaning across the entire image set. And so I told Marijn, who was still drudging away with his solutions, he said, "You can forget about what you're doing. We have the solution." And it was really multivariate statistical analysis as was practiced in laboratory medicine already. So we could really transfer our image data and make them appear like patients and blood samples. And we had the solution to our problem. So that was an unbelievable breakthrough. And because then the entire methodology became credible, because we had a tool now to sort images in a quantitative way. And so this is where, so he was in laboratory medicine, and he got so interested in this entire approach that he dropped out of laboratory medicine and became an image processor and who wanted to do image processing using these methods, and he got a position in Houston and practiced this. An undergraduate, a very beautiful undergraduate that worked with my group became his wife. So I didn't have a lot of contact with him afterwards, but one of my postdocs who were also settled in Houston had a lot of contact with him. His name is Paul Pensek.
Someone like Jeanpierre who dropped his ongoing research to join your group to work on image processing, that's just a story. That's simply science fiction to me today. I very rarely meet people who are able to be so passionate about what they do. So the quality of the students in general, it didn't drop in the sense of that, okay, they don't know as much. It's just that they are not driven by the same things anymore. This is how I feel about it. I don't know what you think.
Well, I don't know. I mean, you simply need some kind of an 80 fix, and you want to pursue it. And to be honest, I very often I thought I'm not going to get anywhere with this whole idea. I didn't have a lot of believers in it. The progress was very, very slow. At one time, I remember it very clearly. I was invited to come to Göttingen, and there was a collaborator of mine, and we used single particle averaging, not reconstruction, averaging on acetylcholine receptor. So I was sitting in a plane. They paid for me to come there, okay? And I sat in the plane and I said, I mean, this is mind-boggling. It's mind-boggling because on the force of these very pathetic, poor-looking averages of the acetylcholine receptor, which just had a resolution of 50 angstroms or so, and why am I being paid for the whole expenditure of energy to bring me from one place here to over there because of these pathetic looking images? This is unreal. Okay. So I had moments like this where I thought that this I'm sort of a fake here.
Do you see that people or scientists have changed over time? Do you still find the same kind of interested and interesting people who want to join your group from time to time, or this is a different era now?
Well, I think the competition only got harder in science. It was relatively easy for me to get grants in the beginning. And meanwhile, you almost have to become 50. You have to wait until you turn 50 before you get in your first real grant. I mean, this is insane. This is an insane system. So the point is that it was probably a bit easier during my time to profile yourself, to stand out. Meanwhile, it got a lot harder, and the knowledge base increased so much. I find it a student nowadays must find it difficult to even identify a career path, to identify something that is worth working on.
Right. Yeah, totally. It's still very. I mean, it became very cryptic. I mean, when these students come to see you, you don't know whether you should promise them a future, a job, a thesis, or whatever. It's just all out there, and so many uncertainties, a lot of investment, a lot of sacrifices, and at the end, make sure they get a job. It's terrible to be a scientist today. I mean, in many ways. Which brings me also to the beginning of this whole interview about my dinner with Andre. This is how the movie started. If you recall, you had Wallace wandering the streets and talking about how difficult it was to be a playwright, to be an actor, theater actor. It's in a way I relate to this character.
Right. It's really, when you get older, then all of a sudden you discover it's all about what to do with your life. When you have to, in some way, there are stages where you think, there's so much time still to do what you really want to do. And then that time gets smaller and smaller, and then you really have to make a decision to actually make the jump. You have to make choices in what you want to do. And I'm very fortunate that I'm at a place now where I can divide my attention between different things that I all like to do, and not everybody has this kind of opportunity.
Absolutely. So, if I ask you what advice would you have to any young scientist or wannabe scientist person who would start thinking of having a PhD, for example, in order to pursue a career as a researcher? What would you tell such a person today?
Now, I already have an answer stored up on this, because I've been asked this several times in different forums. So there are two things that really stand out for me in my own experience. One of them is the role of completely accidental events in for your science career. There are so many unexpected things that happen, and the important thing is that you take advantage of them. You have to sort of look sideways. So peripheral vision is a very important thing. You cannot ignore the things that come from the sides, completely unexpected. You cannot ignore them as opportunities to rethink your entire approach. And So very often crucial crucial signals come completely from the outside, completely unplanned. So that's one thing. The other thing is that in my own experience, I had to develop the approach that I developed in really pretty much in contradistinction to what my mentor wanted. So I prevailed, fortunately. And so if you have something that you have scrutinized and checked and you think it's going to work, it has a chance of success, don't let yourself be talked out of it. So one has to be stubborn, and even if it runs counter what a mentor tells you.
That's amazing. It doesn't.
That's probably very hard to hear from somebody who is a group leader right now, right? So I just remembered that our whole acquaintance goes back to something like a dinner in Heidelberg, right?
Absolutely, yes, you are correct.
So that was the first time that we were on the table, and you came over from Strasbourg, and I just happened to be in Heidelberg at the time,
yeah,
and then you told me about your trepidations about meeting me and so forth, but it went very well, and you immediately convinced me that you were the right kind that I needed in my group.
Oh, I have to say, okay, this is probably one of the best things that happened to me. I never did cryo-EM. I was following it from far. I was so naive back then to think that the problems in cryo-EM were simply engineering problems, nothing else, because everything was there. And I took the bet that while I am in postdoc, there will be a significant improvement, which actually happened. I don't know how. It's like a miracle. I entered the field like old timers, scanning micrographs and picking particles manually. And then I exited. When I left your lab, things were pretty much established, and we were at near atomic resolution already. And that was in the space of 4 years and a half. It's simply amazing.
Yeah.
I remember that very well that evening. So we met in September 2009. That was a couple of weeks before my defense.
Right, and it was just a year after I went to Columbia.
Yeah. Actually, I'm glad you brought this up, because this is a question that I had never asked you. You can answer or just skip it. That was the time when just a couple months before the Nobel, or a couple of weeks before the Nobel laureates were announced.
Yes.
For the ribosome structure. I didn't know enough about the ribosome back then, but your name was always among the top 3, let's say, potential laureates. And you were not for 2009. And you were awarded the Nobel Chemistry 2017 for cryo-EM.
Well, it's really, it's a numbers game, right? There were, if I had been considered, then 2 additional people would have had to be considered too, which is was Harry Noller and Peter Moore. They were certainly, I think they were probably more qualified than I, but I think the 6 of us would have deserved the Nobel Prize, but then they singled out the X-ray contributions. And the way it worked, you could not pick 2 X-rays and 1 cryo-EM. It wouldn't have worked. So the the three really had the contributions, the long year contributions that got them structure. They were not, in 2000, they really were not at the point where they could characterize function. Even later on, X-ray crystallography alone would not have managed to get us all the functional insights that come out of the cryo.
Well, in many ways, I selfishly I would say I'm happy you had it after. So you invited me to come to this celebration, which was just an amazing honor and a very, very inspiring experience for young.
Yeah, I'm glad that you got really on track with your whole research, and you were really one of my best postdocs over the time. Joined me at a very crucial moment, just pre-camera, but post-camera would have been a little more advantages, but pre-camera was among the pre-camera people. You did amazing contribution.
Well, thank you very much, Joachim. For this is really touches me very, very deeply, and I'm very glad that I made your acquaintance and you set me on this path. I'll just hope that I will keep it on, and I'll always look up to you as a fantastic mentor and a friend.
Thank you so much.
Well, Joachim, I think we can have our dessert privately after this interview. So Thank you again for your time, and I hope people will enjoy this.
Okay, it was a great pleasure.
Thank you, Joachim.
Yes, thanks so much. Okay.